For this example, we're going to find all rational zeros and factor f of x into linear factors. So we're given a polynomial. Okay, and again, make sure that it's in descending order with the degrees. And we're going to look at the coefficients of our leading term, the highest degree, and our last constant coefficient. What we want to do is we're going to use our rational zeros theorem, and that basically states we want to look at the last number, which is generally referred to as p, and we want to look for the factors of these two. Okay, so the factors of p are going to be, 1, 2, and 4. The factors of our leading term coefficient 8 is going to be 1, 2, 4, and 8. Okay. So first thing we want to do is to, once again, list possible rational zeros. And for this, our rational zeros theorem states that it should be p divided by q. Okay. So what we want to do is take all of our factors here divided by all of our factors here. So I'm going to start with our factor p is 1 and place that over each of these factors, q. So for p equals to 1, I'm going to go ahead and put 1 over that. For again, I'm keeping that p-value constant. Q is the one that's changing. Now we let, again, this was for p equals to 1. Now we're going to do that same thing for p equals to 2, and we're going to notice that some of these factors, or these quotient, possible rational zeros, do repeat, but we'll just eliminate those right now. So again, now we're in p-value 2, and we're going to divide them by all our q values. So 2 over 1, 2 over 2, and this is again the one that repeats. 2 over 2 is the same thing as 1 over 1, but we'll just keep writing this, and we'll eliminate the repetitions right now. Okay, now we go ahead and proceed to p equals to 4. So 4 over 1, 4 over 2, 4 over 4, and again the repetition, and again this one also repeated. But a lot of these actually will end up repeating. Okay. Now, as mentioned, we're going to go ahead and eliminate the repetition ones. Okay, we know we have our whole numbers. 1, we have the 1/2, the 1/4, the 1/8, and then we've got our 2. The 1 already repeated itself over here. This is going to be 1/2, which is over here. This is going to be 1/4, which is over here. Then we have our 4, which has not showed up. 4 over 2 is the same thing as 2. 4 over 4 is the same thing as 1. 4 over 8 is the same thing as 1/2. So here we have our possible zeros. The only thing is that you will want to make sure that we do put plus or minus in front of each one, because the rational zeros theorem indicates that it could be positive or negative of all these. Once we have this, now we want to go ahead and start factoring, and not factoring, but rather using synthetic division to kind of help us with these possible zeros. And it is a trial and error, so we would just, you can do it just starting with the list, or you can choose at random which one you think will work. Okay. So we're going to be dividing this by one of these right here. Okay. All right, so we're going to put our 8, our negative 26, and again, these are just the coefficients, the way synthetic division works. I'm going to go ahead and put a divisor over here of 1. Okay, and if it doesn't work, we'll just proceed to doing another one. Okay, same thing, we're going to, as synthetic division tells us to do, drop this one down. 1 times 8, I get 8. Negative 26 plus 8, we get negative 14. 1 times negative 14, write that here. We get negative 41, and we proceed to doing these. Now right here, I can kind of go ahead and stop here, because I notice that even here, what I get here, I'm not going to get that, negative 4, so that I'm going to get a remainder not equal to 0. Okay. So what I want to do is try a different one. Like I said, this is just a trial and error, so now let's go ahead and try a negative 1. And I'm just going down the list, positive, negative. You can continue, you can choose at random which one you think will work. So let's drop this 8 here. Negative 1 times 8, I end up with negative 8. I add these two, I get negative 34. Now I end up with positive 34. I add these two, I get 7. Positive 7. Negative 1 times 7, I get negative 7. I add these two, I end up with positive 4. Negative 1 times 4 is going to yield us our negative 4, and here we do get a remainder of 0. Okay. So right here what we actually have is that this one is one of the factors. Now, for us to understand our factors, make sure that you understand that this was x equals to negative 1. You can think of actually that as 0. And to find our factor, kind of move it back over here, we have x plus 1 equals to 0. Okay. So now I'm going to rewrite my polynomial. F of x, is this 8x to the 4th, all this. By the way, our answer here is going to drop 1 degree, so it's going to be 8x cubed minus 34x squared plus 7x plus 4. So I'm rewriting our polynomial 8x to the 4th minus 26x cubed minus 27x squared plus 11x plus 4 equals to our answer, or quotient rather, 8x cubed minus 34x squared plus 7x plus 4 times our factor, x plus 1, should yield us this right here. Okay. Now from here, there's a couple of things that you can do. Rather than starting back with our original polynomial, which you could just go ahead and now just use this polynomial and use one of these from your list. Okay. So I'm going to use synthetic division. 8, negative 34, 7, and 4. And over here again, just going down the list, so this time I'm going to go ahead and try the 4. Drop down the 8. 8 times 4 is positive 32. Add these two, you get negative 2, negative 8, negative 1. Again, I'm multiplying negative 4 times negative 1, putting the product here, adding these. I do get that the remainder is 0. Okay. So now we are at this stage right here where our polynomial, which was now just this one, I want to go ahead and write, instead of 8x cubed minus 34x squared, by the way, our answer here is 8x squared minus 2x minus 1 times this should give us this. Okay. So before we had this right here, now I'm going to go ahead and write 8x squared minus 2x minus 1 times, again, here is our 0. So our factor is actually going to go back to x minus 4. So times x minus 4. These two multiplied together, our answer quotient times our divisor, should give us this polynomial right here. And I still have this times x plus 1 over here. Okay. Now, from here, there's a couple of things that you can do. You could just, continue doing the synthetic division, or you could just factor this out. Okay, I'm going to go ahead and factor out that using the middle term splitting. So I have negative 8. Factors are 1 and negative 8, 2 and negative 4, and these are the ones that I want that add up to the middle term. So I'm going to rewrite 8x squared. The middle term I'm going to split up into, our factors, plus 2x minus 4x minus 1. I'm only going to deal with these, so I'll put these down like I did this x plus 1 at the end. So now these two, they have in common a 2x, and I have 4x plus 1. These two, they have in common a negative 1, and I'll be left with 4x plus 1. So if I continue this right here, I'll be ending up with factoring out the 4x plus 1 that they have in common. That is that this term and this term have in common. And I'll be left with the 2x and then the minus 1. And same thing, I'm going to go ahead and drop this x minus 4, drop this one, x plus 1. So my original polynomial of 8x to the 4th minus 26x cubed minus 27x squared plus 11x plus 4 is now rewritten as a product of my linear factors. So I've done the factoring. If you wanted to get the zeros, all you would do is just set each of these linear factors equal to 0 and solve for x. So I move the 1 over, divide by 4. I get x is equal to negative 1/4. Move the 1 over positive, divide by 2. I get 1/2. Move that over, I get 4. Move this one over, I get negative 1. And so here would be my zeros.